Hello and welcome back to the channel. Today we'll be starting a new tutorial series on making an RTS game in Godot. So think StarCraft, Age of Empires, or Warcraft. In this particular video, we'll be covering unit selection and a movement, so let's get right into it. This is what we have from the beginning, just an empty scene in the game. We'll add a tile set, tile map. Tile, the cell is going to be 32 by 32. Sorry. We just have one single tile for now. We'll expand on it as it goes on. So I forget how to fill, so I'm just gonna do it manually. For the units, we want them to be kinematic bodies in this case, because we want units to collide with other units and not move through them, I guess. And the unit is gonna be the inherited class of all the units. So we'll have like the basic functionality. All of the other units will inherit from it. They won't be children. This is a child of this. We have slightly different terminology in Godot, but they will be inherited classes. So on a unit, we want a collision shape and we want an animated sprite for now. We'll also be adding like a vision area later, and we'll be adding more as the game goes on, I guess. So we'll add a knight over here, speed 8, playing. Yeah, we're good. Actually we wanted to play, so let's save this frame, create folder for frames, and we'll call this knight idle forward frames. So in this case we really only have forward and back frames. So when we are moving in this direction, we will be using the forward frames. When we're moving down, we'll be using the forward frames and just flipping it for when we're moving to the left, and that will make sense later. Anyways, collision shape. We want the collision shape to be a circle at the bottom of the knight over here. There we go. So we can drop down this unit into our game for now, and let's add another sprite over here for selected. So when our unit is selected, we will make the sprite visible. For now it will be not visible. We will attach a script to our unit. So let's talk about what using a kinematic body will mean for us for this game. Basically, it will mean that we'll be using move and slide, which is a built-in physics function in Godot, which allows us to move kinematic bodies, and when they collide with other bodies, they will slide along the edge of them. So let's add a selected variable, and let's add a function selected. Selected equals true. Selected visible equals true. And function deselect selected equals false, and selected visible is true. Game. Now let's move on to selection. So the way that we'll do this is, there's actually a Kids Can Code video on this. So partially this video is adapted from that video. So we'll have a rectangle shape that we'll be using to intersect with select the units. So we'll be changing the size of the rectangle to see which units it collides with, which is another reason why we're using a kinematic body in particular, because it allows us to use one of the functions that we'll need. So what we'll do here is we'll have a dragging variable, and we'll have an array of all the selected units. We'll have a vector2 for where we begin to drag. So when we're like dragging, I can't show it here, I guess. But when we're dragging a rectangle to select the units, this is where we'll be saving the first point of the drag, and we don't need to save the second one because that's we have it. And we'll have, which is a rectangle shape 2D. And another thing that we'll need is just a node 2D over here. Select draw. So when we're selecting a unit, we need to draw a rectangle. And we could draw the rectangle in the game node. However, the problem with that is that, sorry, OCD. The problem with that is that our game node is below the tilemap and the units. So when we were to drag like this, it would draw the rectangle under everything, so we wouldn't see it. So we need another node, and we'll use this node and adapt its draw function to draw a rectangle for us. So it will be above the units, above the tilemap, and we'll put it in unready var. Don't need this. I just don't like the green text, I guess, over here. So the way that we'll be doing this is through the unhandled input function, and we'll be looking at this event in particular to see what type of an event it is, because a couple of events that we need to keep track of. First off, the mouse down and the mouse motion event. If our event, an input event, mouse button and button index button left, if event is pressed, then when this happens, what do we know? We know that we just click the button and we potentially want to start dragging. So in case that we have already units selected, we will assign an empty array to this, because we want to deselect those units first of all, and we want to set dragging to true, because the way that we are keeping track of the dragging is through this variable. And when we later look at the event mouse motion, we want to make sure that the button is actually clicked in order to change the size of our rectangle shape. So we don't want to select units when our button is not actually pressed. So we'll set dragging to true. We'll set drag start to the event position where we started our drag. And otherwise, what this does is basically it's either event pressed or event released, right? So if we're dragging, we want to make sure we get all of the units that we selected. So first, when we start dragging, sorry, let me get to the game node. So when we start dragging, this is the event pressed, and when we release it, we want to do all of the logic that goes into selecting the units, right? So that's what we will do right here. We'll set dragging to false. Make a new variable, drag end. The reason why we're declaring it here in particular as opposed to here is because we're just going to be using it in the logic over here. We don't need it outside of this function. So it's basically a local variable to this function. Rectangle extends equals drag end and minus drag start divided by 2. The reason why we're dividing by 2 is because our rectangle that extends just shows how much the rectangle extends from the center, I guess. So we need it divided by 2. Next we get the direct space state, which is we get the world 2D direct space state, which is just the space of all the physics objects in our world, in our game, basically. So our world 2D has our canvas in it and this. Next, we want to ask something of this direct space state, making a query physics 2D query parameters dot new, and of the query we'll set shape equals select rectangle. So this will be the shape of our query. We're gonna be wanting to ask what this direct space state bodies, this direct space state in particular, has within the shape that we're sending it. So that's why it's called a query. The transform, which is just our position, was transform 2D. Set the position to drag end minus drag. We set our drag end plus drag start divided by 2. So drag end plus drag start. Why are we doing that? So let's say our drag end is over here at like 4x and 2y, right? And drag start is at 20x and 20y. So 4x plus 20x is like 24, right? 2y plus 20y is 22. So we divide that by 2 and we get the position in the center of the rectangle. So we have our transform, which is the position in the center over there, and our extends the half of this minus this, right? And our selected is base intersect shape query. So far, what we've done is the event pressed and event released events. And we just want to check what we get from this. So print selected. Right? So hopefully vector 2 not extends, it's extends. Sorry about that. So what we get is actually a dictionary, right? So this is our only thing in the dictionary. So what we want from the dictionary is actually just a kinematic body, not its collider, not its metadata, not anything, right? So for unit and selected, and here later we'll actually be checking if it's actually a unit as opposed to a building or something. So if we're selecting units, we just want to select units. If we're selecting buildings, we just want to select buildings. So we'll be checking for groups later in this part. But for now, it doesn't matter because we only have one unit and it's only so unit, for unit and selected, we want to get the collider because this is what it is. Selected, right? Sorry, not selected, select. I specifically changed it from selected to select. Yeah, select. Right? So now we want to make sure that here for unit and selected, we want to deselect. Unit, I believe it's still a dictionary, so don't change that. Unit collider deselect. right? And it's not deselecting them. Interesting. So the problem was that we weren't actually setting it to false. So, oh well. Selected, deselected, selected, deselected. So that's what we have. Now, what we want to do is make sure that we draw the rectangle. So, and what we'll be doing here is attaching a script to the select draw, and we'll be checking its draw method. So we want to draw a rectangle on top of everything, and that's why we have a separate node from the game node in order to do this. And the way that we'll be doing it is by having a couple variables in here. So draw start equals vector to 0, drag end vector to 0 bar dragging equals false. We'll be placing an update status function, and we'll be doing start and drag in here. So drag start equals start. I'm really misspelling a lot of things today. Drag end equals end, and dragging equals drag. We will be calling the draw function. So what this function is just calling our draw function inside of the node. So usually what the draw function does for sprites is it would clear the canvas, or like clear whatever it drew before, and would draw an updated version of whatever we're dealing with. In this case, it will be a rectangle based on the variables that it has. What we want to draw is, if we're dragging, then we want to draw rect, and we want our rect to be a rectangle 2, start, drag end minus drag start, and we'll have our color. In this case, will just be 1, 1, 1, which is just going to be white, and our filled boolean will be false. Right? So dragging that thing is done in the game. So we have these two events, but we need a third event to handle this thing in particular. If we are dragging, and if event is input event mouse motion, we want to select draw update status, and we want to give it event position, right? So we want drag start event position, so that's the end, and dragging, right? Select draw update status. So that will make sure we're drawing our rectangle when we are dragging. However, once we stop dragging, the problem here is that our rectangle will just remain there because the draw function is not updated. When we update it, the draw function clears it first, and then it draws whatever it needs to draw. So when we update it and we're not dragging, we're just going to clear and not do this, right? Let's add a couple more units in here. So So there we go. Our selection is working.
So now that we got the selection working, let's move on to the unit movement. So we'll have a function move to target inside the unit. So set target to tar, and of course make a variable target. Can't forget about that. Vector to 0 for now, right? We want a variable velocity equals vector to 0, and a variable speed, which in this case we'll set to 80. Target max, which is gonna be our basically how far we stop from the target, how far it is okay to stop from the target, which just set to 1. We will check if our target, if our position is close enough to the target, close enough meaning within this, in our physics process. And if it's not, we will move towards it. So in order to make sure that our thing doesn't get triggered and we don't move to vector 2, 0, I'm just gonna set target to position on ready. So that's what we're gonna do. And we're gonna make a physics process. Function physics process delta. Do we need a delta here? We do need a delta here. So set velocity equals vector to 0 over here. Position distance to target greater than target max. So if we're farther from the target than this, which is 1, we move towards the target. Velocity equals to position direction to target times speed times delta. Oh no, we don't. Because our move and slide actually takes into account the delta, so we don't need the delta at all over here. So we can move the thing, velocity, move and slide, velocity, right? So the reason why we're assigning velocity to move and slide is because move and slide returns a velocity that is resulted in us colliding with other objects, so it kind of alternates the velocity, but then we set it to 0 because we don't really care about that. We just want to slide a little bit. We don't want to do like a full-on physics. So yeah, let's see if our units don't move, because we need to, in the game object, we need to add another thing. So if event is input event mouse button and event button index equals button left, button right, and if event released, is that a thing? I don't know, we'll find out. Expected assign, of course. Event released, we'll find out if event released is a thing. Obviously you could do this whole thing with like input is button pressed. Like you could adapt this, but I already did it this way, so I'm just used to looking at this code with this type of event checking, I guess. Event released 4 units in selected. We move units collider move to event position. So if we release the right mouse button, for every unit and selected units, we tell them to move towards that position. That's what's going to happen, hopefully. And it doesn't happen because released is not a thing, so we'll just do pressed, whatever. Oh, Jesus, that's fast. Okay. Right, I forgot about that. So what you'll notice is that two things. First of all, units keep moving because they don't actually reach the target if there are other units over there. And second of all, units that are supposed to be behind other units are not actually drawn as behind. So we'll solve that last thing first. And the way that we're going to do that is by adding a Y-sort node and drop all of the units over here and move the Y-sort below the select draw. So what a Y-sort does is it basically makes sure that if a unit's X position, Y position, sorry, is greater than another unit's Y position, it is drawn above it, right? So it kind of affects their Z index in a way, and it doesn't do anything else. So these units are just going to be sorted, kind of. Their Z index is going to be sorted based on their Y position. So what this will do is that units that are below other units, they're going to be drawn above them. So that will solve that. And second thing is that we want our units to stop moving once they realize that they can't get to the target, I guess, because there are other units blocking them. So our movement code is going to be very simplistic for now, and later on in the tutorial series we might we'll be implementing more complicated pathfinding, again probably with flow fields, if I'm remembering the name correctly, but it seemed very promising. But for now, to keep this tutorial short and concise, we'll stick to very simple movement. So what we're gonna do is we are going to make sure that our units just stop when they can't get to the target. And the way that we're going to do that is by basically getting the collisions of the units. So when a unit collides with another unit, they will start a timer that at the end of the timer we'll be checking again if they're colliding with that unit. If we are colliding with a unit, we start a timer. Once that timer finishes, we check again if we're still colliding, and if we're not closer to the target than we were when the timer started, then we stop moving to the target and set target to position. I'm sorry, that was a lot, but hopefully as I make this, it will become a little clearer. So slide count, we'll just keep track of our collisions. Move threshold equals 1.0. So this will be how much closer we need to be to the target from when our timer, which we'll add right now, move timer, from when our move timer started, which will be a one-shot timer with a 0.1 second wait time. This is how much closer to the target we need to be when this timer started to keep moving as opposed to stopping. We'll save our last position, our last distance to target. We don't really need this variable. We can just calculate everything from when we get it, but it's more convenient that way. And our current distance to target equals vector 2, 0. What we're gonna do, if get slide count, so if our slide count is more than 0, so we can just use this as a boolean, and stop timer, sorry, on ready var equals move timer. Let's rename this to stop timer, because it's not stop timer. Stop timer is stops. Stop timer start last position equals position and last distance to target is last position target last position distance to target. Right, so once that timer completes, on ready var stop timer. Once the timer completes, we are going to connect the timeout to our unit, and we will check if we're, first of all, I realize we don't need this variable, so we're gonna get rid of it. Get slide count. If we're still colliding with something, right? So there's something in our way. Get current distance to target equals position distance to target. And we also don't need last position either, I think. So here, if last distance to target less than current distance to target, move threshold. Threshold position target equals position. So if our current distance to target is, say, 10, and our move threshold is 1, so together it's 11, and our last distance to target was like 12, so we got closer to the target by 2, which puts us over the move threshold, and we can keep moving. But if we got closer by what, like only 0.5, then we will be stopping, right? So that's how this works. So let's see how this turns out to be. Right, so our units stop and don't move anymore. But for some reason they stopped over there. So let's move up our move threshold a little bit. Wait, I'm increasing it when I should be decreasing it, right? 0.8. Units still stop, 0.5. All right, so I figured out what the problem was there. And all the extra variables actually got to me. So we got rid of all the last distance to target. We're just saving the last position. So here's our last position variable, and on get slide count and stop timer stopped, we first of all moved it within our movement code, because we don't need to check for this outside of the movement code. We don't need to stop if we're not actually moving, right? So this was over here before, it's now here, and our stop timer timeout is actually way simpler. So last position distance to target is less than position distance to target plus move threshold, and then target equals position. And this is what we get. Our units move, and once they get there, they stop. And for some reason before, at some point it was calculating, it was wrongly calculating the distance to target, so it was just overshooting it by a lot. Anyways, so that's that. We will be adding some animations to our knight, and do the same for all the movements. So we'll be loading all these frames for idle forward. So from here we'll just be making sure that our frames update properly. If you want to stick around. I'll be covering that as well. But for the next episode we'll be adding enemies and attacking those enemies. So if you want to see that, please subscribe, and I'll see you in the next video. For those of you who want to see actually adding the animations, stick around. Anyways, so for the units, we'll be adding an update sprite function. Sprites plus, and if velocity is greater than 0, velocity x is greater than 0, we will be adding another onReady var animated sprite. Sprites animated sprite h equals false, and if velocity x is less than 0, sprite flip h equals true. When we're moving to the right over there, our sprite needs to be not flipped, because our unit, all our sprites are looking in that direction. So it's fine if we're we're not flipping it when we're moving into the right, but when we're moving to the left, we want to flip it like this. So that's what we're doing over there. So left flip h, true, right? And when our velocity is 0, we don't want to flip it, so we want to stay looking in the direction we were looking at when we were moving. So that's why we only do less and greater than. If velocity is greater than 0 and sprite frames not equals to walking velocity walking forward frames, then we set sprite frames equals walking forward frames, and sprite frame is equal to 0, and if velocity y is less than 0 and sprite frames not equals to walking back frames, then we set sprite frames equals walking back frames, and sprite frame equals 0, right? And now so when we're moving to the right, we want to not flip the sprite. When we're moving to the left, we'll flip it if our velocity is greater than 0 and our sprite frames are not walking. So if we just started walking, we switch the frames to walking frames and set the sprite frame to 0. So we'll start from the beginning of the animation. And same thing for the walking up as opposed to down. We set to walking back frames, and yeah. So now the one thing that we need to do is if velocity length is equal to 0 and sprite frames not equals to idle forward frames, or sprite frames not equals to idle back frames. Then we want to, if sprite frames equals walking forward frames, then sprite frames equals sprite walk idle forward frames, and sprite frame equal 0, and with sprite frames equals walking back frames, then we set sprite frame equals idle back frames, and sprite frame equals 0. Right, so if our sprite frames are not idle and our velocity is 0, then if our animation is walking forward, then we set it to idle forward, and if it's walking back, then we set it to idle back. So that should give us nothing because we didn't update sprites over here, and we want to do that. Update sprite over here. Oop. Not equal to frames. Right. So that's looking good. Alright, so we got our movement down. And our selection down again. In the next video we'll be doing we'll be adding enemies by just kind of recoloring them and giving them some AI possibly, but what we mainly will be working on is finding targets and going to those targets and attacking those targets and kind of dying. Anyways, thank you for watching. Subscribe if you enjoyed the video, and I'll see you next time.